Hello, and welcome here at Bodo's Wide Bandgap event 2022. My name is Marc, and today's topic is bringing ringing under control, which means we are talking about the ringing in a high power application and how you can reduce that. But before we do so, I just want to say thanks to Bodo and Holger for organizing this event and inviting us for this presentation. But now let's get started. As you probably know, there are many new applications which are going to be electrified. Most of you will think about the combustion engines, which will be electrical motors in future. But there are many other applications which are already electrified, but needs to be improved to support the decarbonization of our future sustainable green Earth. What is important for those applications? Efficiency needs to be improved, size and cost needs to be reduced, and many more things. And key for that is wide bandgap, in our case, silicon carbide. So we can say SiC-ification of everything. Here you see some of these examples, like the transportation sector with classical electric vehicles, buses, trucks, trains, aircrafts, and more. But also industrial system, renewable energy system, data center, and many more are looking into silicon carbide to improve the efficiency, size, and cost. But what is also important, we think reliability and ruggedness is important because no one wants a failure in their system in the field. So the choice of rugged, reliable components and also a good design is important to those applications. If we just consider the components itself and what is important in terms of reliability and ruggedness, here a very brief overview what we think is important to consider. Starting from the gate oxide integrity, having a robust body diode which is not degrading so that you can use it in your application. Then high avalanche capability because you always have any spikes in your system when you're switching inductive loads. And last but not least, short circuit withstand time and short circuit behavior itself. That all is important for choosing your next silicon carbide MOSFET or diode, and many more topics for sure. And guess what? Microchip is supporting that very well. Now let's come to the main topic of today, which is the ringing in switch mode power supply applications. It is caused by the parasitic inductances and capacitances of your components and your system design. And when you turn on and turn off your transistor, and you can do that very fast with silicon carbide, you get an overshoot and a ringing in your system. And especially if you turn on and turn off high currents, high voltages, it can cause a lot of problems like EMEA, EMC issues, additional losses, and also can cause damages of your system. So you want to get rid of this. So what can you do to reduce your overall ringing? First of all, you should consider your parasitics in the system. And you can change or improve that by a good board layout, but also by a good choice of components. Especially if you are looking for power modules, there are big differences in power module parasitic inductances. Furthermore, you can slow down your transistor by choosing a higher RG, so gate resistor. But there's also downsides because you make it more slow, you have much higher switching losses, which you don't want to have in a high efficient system. You can also add snubber electronics next to your transistor. This furthermore reduces your overvoltage and ringing, but it has also downsides. First of all, the energy must be taken anywhere, and it's done with the resistor in the snubber electronics. So it must dissipate the energy, and that are further losses. And if we are talking about high voltage systems, especially in automotive, the capacitances you need for that may be very expensive or hard to get. So what else can we do? Or better to ask, how can Microchip help you further reducing your ringing in the system? And we have two topics which we want to address today. First of all, how can we help reducing the parasitics in your system? So if you consider the different power modules in the market, you see there are big differences in strain inductances. Here are some examples, just 3 examples of Microchip modules, which is a standard 62 millimeter package and improved versions of that. And here you see the differences in parasitic inductances or strain inductances cause different kind of overvoltages, and you can reduce it by reducing the parasitics here. And here is a highlight our so-called SP6Li power module. You see it has a strain inductance of down to 2.9 nanohenry, which is really unique in the market. And it's designed for very high power applications up to 750 amps. And because of the low strain inductance, you can really use the features of silicon carbide. So you can generate a high efficient system with less ringing. But what else can we do? So let's consider the gate drive itself. And Microchip has a technology which is called intelligent augmented driving technology, which is also unique in the market. But what does it mean? Let's start considering the classical way of driving a transistor. Normally, you turn it on and off in one step. Maybe you have different RGs for on and off. Or you also have different RG for fault conditions. But what you can influence is just the total slope here. But why not turning it on and off in steps? Because the turn on and turn off behavior of a transistor is not linear. You have different situations. You have the threshold moment, you have the Miller plateau, and then the rest of turning on or off. So could it make sense to turn it off in steps, like you see here with our first generation of gate drivers, or even more, also turning on in steps with the second generation of our gate drivers? With that, you can much more influence the behavior and find a good balance between losses and ringing. Let me explain that on the next slide. Okay, let's consider a simple example. First of all, we're turning off the transistor in one step from plus 20 to minus 5 volt. No step in between. You have your overvoltage, you have your ringing, and you have your losses. Let's consider the opposite. So you turn it off from 20 to 4.5 volt first, wait for 650 nanoseconds, then you turn it off to minus 5 volt. What happens? The overshoot is reduced a lot and also the ringing, but on the other side, you have higher switching losses because it's switching very slow. Maybe in your application, it's okay. But if you want to find the balance between both situations, maybe you need to implement a little step in between to go to 0 volt and for 50 nanoseconds only. So you can reduce your overvoltage and your ringing, and you can further reduce your switching losses. And the nice thing is you can do it just with a keystroke. You don't have to resolder anything. And here you see an example of a development kit, which is called ASTAC Plus or ASTAC development kit. And what you get is the gate driver itself, the power module, in this case, the SP6Li, and also a programming tool and a software, so-called ICT. And with the ICT software, you can change the parameters of turning on and turning off graphically or by entering parameters. So very simple. And you can easily find your perfect balance in your system. And if you further need help, contact us and we are going to help you. But let's discuss details in the question and answer session. Last but not least, I just want to do a little advertisement about the Microchip products. So you see, we have a broad portfolio from 700 volt up to 3.3 kilovolt devices, diodes, transistors. We can offer that as a die to you. We have discrete solutions in many different packages. We do have power modules. We can offer you standard modules, but also customize those standard modules for you if your application requires that. Or we can also generate complete custom modules. And last but not least, the augmented gate driver, which I showed you today. With that, I'm at the end of my presentation and I want to say thank you for listening. And if you have further questions, contact us or take a look on our webpage, which is www.microchip.com/SiC. And now I'm looking forward to having a good discussion with you. Take care and goodbye.